Assalamualaikum to Madam Farah. We are from Group 2 and today we would like to present our findings for Lab 2 on input-output programming using assembly language. So basically, by the end of this lab, we were expected to be able to program a simple input-output programming by using STM32F446RE via Kiel. On part 1, we did a simple programming to produce an output for LED, and for part 2, we constructed the connection of push button and LED as input-output respectively on three conditions. So next, we will proceed to the next part of the presentation, which is the procedure.
So first, we move to the procedure part 1. We need to set the connection of LED in the breadboard as shown in figure 2. Then write a program using STM32F446RE microcontroller assembly language that will turn on LED D1, D2 and D3 and then turn off those LED. Next, we need to load the program to the microcontroller and explain the finding in the report. Next, we need to modify the program so that the LED will turn on one by one, starting from LED D1 until D4. So first, we move to the manual lab. So as we can see here, we need to analyze the circuit first. So at D1, D2 and D1, D2, D3 and D4 are connected to the 5 volt voltage which produce the active high input. So we need to enable the microcontroller we need to put the active low. So we move to the first to enable the port B. As we can see, we put the logic high 1 in the port B which produce the value 2. Next, we have GPIOB MODR model which enable the port for 5, 8 and 9. So we put also the logic high. So the value would be 0 times 0, 0, 0, F, 0, F, 0, 0. So this one for the BIC. So we proceed to the ORR. So we need to put the 0, 1 in port 4589, which is the value would be 0 times 0, 0, 0, F0500. So next, GPIOB ODR, which is we have two conditions. The first one, we need to on the LED D1, D2 and D3 to put the logic low in this value, in this program. So after we put the value, the value would be 0 times 0, 0, 0 FECF. So for the next condition, we need to turn off the D1, D2, D3, which is in active high. So we put all logic high, which produce the value 0 times 0, 0, 0 FFFF. So this one manual for modify the program to turn the LED one by one. So as we can see here, there is 4 condition, which is the first one to turn on D1. So the value would be 0 times 0, 0, 0 FFEF. The next condition, we need to turn on D2. After key in the active, the logic low, the value would be 0 times 0, 0, 0 FFDF. For the third condition, we need to turn on D3 only, which produce the value of 0 times 0, 0, 0, 0 FEFF. And for the last condition, we need to turn on only D4, LED D4, which produce the value of 0 times 0, 0, 0 FDFF. So this is my coding. As you can see here, I put all the value in the coding. So this one for enable port B, this one for enable port 4, 5, 8 and 9. This one for on the LED D1, D2, D3, and I put delay for 400, and then we move to the off LED D1, D2, D3 and D4. So the result will be this in this video. So as we can see here, only D1, D2 and D3 are blinking at the same time and D4 does not blinking. So that is from part 1. So we move to the part 1.2, which is, this is the coding. So basically at the first row are the same, which is this one for enable port B. This one enable port B for 5, 8 and 9. This one turn on by one by one, which is the first one, LED D1, and next D2, D3 and D4. So the result are in this video. So as we can see here, the LED are blinking one by one, starting from D1 until D4. So that is all from part 1. Farida will continue part 2. Thank you.
Thank you, Emilia. And now we are proceeding with part 2 of this lab. Construct the connection of push buttons and LEDs on the breadboard as shown in figure 3. Next, write a program using STM32F466RE microcontroller assembly language that operates as follows. When the S1 being pressed, LED D1, D2, and D3 will blink, all LEDs on and all LEDs off. When the S2 being pressed, LED D1 until D4 turns on one by one. When no push button being pressed, all LEDs off. Load the program to the microcontroller and explain the findings in the report. Next. Okay, first we are going to do the circuit analysis as we can see on our figure number 3. So we have our LEDs connected to port port B of our nuclear board, and the switches are connected on port A of the nuclear board. And for LEDs, they are in active low because we have to set our STM32F466RE board in to give a value of logic 0, while for our switches, it is also in active low condition because they are nearer to the ground. And to do this part, first we have to know the address of all our RCC, GPIO, model, and GPIO IDR and ODR. For our RCC, AHB1ENR, we know that the addresses used are 0x400 to 3830. While the GPIOA model, we have our address of 0x400 to 0000. While GPIOB model, we have our address 0x400 to 0400. GPIOA IDR, we have our address 0x400 to 0010. And lastly, GPIOB ODR, we have our address 0x400 to 0414. And then we have to do analysis on the value needed for our program. First, we need to find the value for our RCC AHBIENR. To on port A, we need to put logic high on port A. Therefore, it will give us a value of 1. While to on port B, we will give logic high as well into port B, and it gives a value of 2. Next, we will need to find the value of GPIOA model. So we are going to put logic high on the pin that we use. So therefore, we have pin number 1 and pin number 4. And by giving a value of 1, 1 into the model, we will have value of 0x000030C. Next, for GPIOB model, we will have a value of BIC equals to 0x000F0F0F00. And for our ORR, which is to set the model as output port, we will have value of 0x00050500. And then next, we will have GPIO IDR. Firstly, we will have a masking, which a value of 0x00000012. And then when switch 1 is pressed, we will have a value of 0x00000010. While when switch 2 is pressed, we will have value of 0x000002. For GPIOB ODR, which is the LED, when switch 1 is pressed, we will have two conditions, on and off. So for the on condition, we have the value of 0x0000FECF, while for the off condition, we have value of 0x000000FFFF. And then the second switch press, we have four conditions. LED1 on, we have the value of 0x0000FFEF, while LED2 on, we have value 0x0000FFDF. LED3 on, we have value 0x0000FEFF. And while D4 is on, we have value of 0x00FDFF. And next, we will proceed with the coding. Okay, for the coding, we will start with our coding with giving the value of addresses that we have gotten from the table. And then next, we will proceed with enabling port A and port B. And then after that, we will set the port as we will enable the pin of the port and then set the port as output or input. And then next, we will check for the condition of switch. If switch 1 is pressed, and then it will go to switch 1 loop. While when switch 2 is pressed, we will go to switch 2 loop. So when switch 1 is pressed, we will have all the three LED, D1, D2, and D3 on. And while when switch 2 is on, we will have LED D1 on, and then LED D2 on, and then LED D3 on, and then LED D4 on. Okay, next we will proceed with the video of part 2. As you can see from the video, when switch 1 is pressed, all the three LEDs will turn on, while when switch 2 is pressed, LED will turn on one by one, starting from D1 to D4. That is all from part 2. We will now proceed with conclusion by Eva.
In conclusion, through this lab, we managed to execute simple input-output programming by using STM32F446RE by learning firstly how to manage the various GPIO configurations RCC table to get the desired input and output, which then is translated to assembly language before we loaded it into microcontroller. And therefore, our objective for this lab has been achieved. Thank you.